Hello everybody, welcome to another boring programming stream. I'm Errichto. Today I think I will mainly solve some Codeforces problems. It's sometimes loud here outside. Hello Kunal, Math Buddies, Snake. Why you think defining temporary variables within a for loop is better than making it global? Just make variable visible only where it's needed. Otherwise you will mistakenly use a different variable or reuse some value unnecessarily. There is some question about binary search. I will read that in a moment. Hello Seal Panda. Let me just check really quick whether Twitch and YouTube work. The last time YouTube didn't work and it was just something wrong with Google servers, I think. Twitch, we're live, and youtube.com/Errichto2. We're live. Cool. Hello Abdul. You didn't check the subtitles. Apparently I didn't have time for that. Resources to learn about DP for beginner. Is that a question? There you can Google dynamic programming tutorials. Hello Shroud. So Math Buddies helped me with subtitles for one of DP lectures. It's just that I will check them, I will review them when I have time, obviously. Congratulations on your winning to top 25 Google Coach, thank you. I didn't feel like it was very hard this time. I mean, I didn't feel that my performance was very good. Maybe I just got lucky with problems. Why subtitles? Like your English is very good and your voice is very clear. But it isn't perfect, plus there are some people who watch and their English isn't perfect and they might get trouble understanding even perfect English. For them it's better to watch with captions. I remember the same thing when I, like 5 years ago, maybe 8-10 years ago, when I watched, I don't know, movies or YouTube, I would prefer doing that with captions on. When will that video be dropped? I think during this weekend two DP lectures will be out. Errichto for gold. Yeah, I think my chances for gold are like 1%. Just remember that Gennady won last 5 code jobs. Concerned about binary search on double. I prefer use Allen size of interval. That's an interesting alternative. Target is 10 to 18. While that the thing is it's impossible to get precision, that small precision for that big numbers. Yes, anyway, the code won't find the square. For not big numbers, your code won't find the square root. It's so loud. The precision of your code is for sure bigger than that. In problems, I mean, a problem, either values will be smaller or they will ask for relative or absolute error, and then we should check that instead of just an absolute error. It's possible to get precision for that many numbers. Anyway, the precision of your code is for sure bigger than that. In a problem, either a problem from a contest, either values will be smaller or they will ask for relative or absolute error, and then we should check that instead of just an absolute error. Here we go. Could you do a video on solving and explaining those problems in your last Google Code Jam round? They have editorials, so I don't think that's very important. Do you have air conditioner? I have, but it's not one of those good air conditioners. No, there are two types. There is something like that goes outside of a building, and then it's very good. And then there are those that, I think like that, those portable small ones that just, they have an option of humidify. Is that a word? They put water in air, plus they have a fan. I have one of those. Make single problem solving videos like before. I will solve some problems. For now, I'm focusing on dynamic programming lectures. I want to make them within a week, because then I go abroad for 3 weeks. Send me second video and make subs for that as well. Calm down. When I have a video, I give it to someone to make captions. What are you doing on dynamic programming? When are you doing? I answered that. Two lectures are already done. I'm starting my account on Fiverr. If you review my work after that, I will be grateful. I think I would have to be your client then on Fiverr. We can talk about it in brief, not here in chat. It's not something that like it's for everybody to discuss. Is there something else? Codeforces. What is it? Rated range 2800. By the way, now you can reach here from @coder discuss. Oh, cool. They put a link to Codeforces discussion. Very cool thing. Having your new account logged by Facebook is a standard process of account creation at Facebook. Good to know. So some people have troubles just creating an account in Facebook, so they cannot participate in Facebook Hacker Cup. The Hacker Cup round is already going. I think qualification round. It starts today and lasts for 3 days, for the whole weekend. Make sure to participate. I think, yeah, everyone who solves at least one problem correctly will advance to round 1. Round 1 is June 29th. do participate. I personally want to one live stream on complete search based on competitive programming, handnote, and Codeforces problems. I have no idea what you suggested. Want to one live stream on complete search based on competitive programming, handnote, and Codeforces problems. What is complete search? Is it like recursion, something like that, where you iterate over all possibilities? We can all contribute so Errichto can have a good air conditioner. It's not that I don't want a good air conditioner. It's not my apartment. Everybody in Warsaw just rents apartments, and I cannot destroy a piece of wall. DP lectures are what everyone wants. Maybe. You feel comfortable doing videos. Just I'm waiting for fall. Summer, I don't like summer. Contests. I couldn't participate in the last Division 1. I think I will go through those problems. Not necessarily implementing them, just at least to read them. First Division 2. I will go through those in this order. Destroying wall stream. That's an interesting idea. Plus, I forgot to make chat visible. Now it should be. Sorry for that. Oh, by the way, I think I completed an SRM, like problem. I have the whole problem set for top code around, and I guess within a month or so there will be my top code around. I hope. Still some problems need to be accepted by Misov, the coordinator, but I hope it does. Why is the chat? Why does it not work? There's just a blue rectangle now. I think, close Windows because it's so loud. Settings. Embed in stream. Copy. Done. Doesn't seem to work. Why is it always so hard? RIP, yep. Streaming on two platforms, YouTube plus Twitch, has its disadvantages for sure. I have to change descriptions, titles in both, maintain both generally, and this combined chat feature sometimes doesn't work. Does it work here? Yes, it does. Test 3. It works here, it doesn't work in OBS. Test 4. Well, messages are displayed by I don't like the background. Oh, yay, it works. I had to generally toggle some buttons on, then off, basically refresh stuff. Apparently now it works. Out of context suggestion, you should open an account on Patreon. I don't need it. Really, I'm fine. Okay, so this is round 564, division 2 plus 1. I will quickly go through problems. Still, I don't have Linux on my PC currently, and it's inconvenient for me to code. Maybe I can install something today on Windows. But likely I will just solve problems without coding. What is Patreon? You can Google it. It's a platform to donate to content creators and artists. X persons who would vote, Y who don't vote, and there were also another Z persons who would vote, but you don't know whether they would vote or not. Okay, we're given votes, or we're given the number of people that will vote yes, no, and they don't know. And we should check whether for sure the voting will be 1, more people will hit plus than minus, or not. And basically those uncertain, you should check whether what happens if all of them vote yes and if all of them vote no. Chess. Hello SM. One day she invented a game by herself which needs n chess pieces to play on chessboard. When are you doing lectures on DP? I did some of those. They will be published this weekend. The rows and columns are numbered from 1 to m. We denote the cell on the intersection as RC. The game's goal is to place n chess pieces numbered from 1 to n on the chessboard. The distance between two pieces on that chessboard must be at least equal to the distance of indices. That's quite artificial. The smallest chessboard on which you can put n pieces according to the rules. It doesn't look like an easy problem. Wait a moment, we are given positions. Oh no, this is the output. Okay. So we need to put pieces on a chessboard so that this condition would be satisfied. What means if there are a lot of pieces, the distances between them must get bigger and bigger because the distance between indices is quite big. It looks harder than your average div2b problem. Please have a look at the tutorial of this problem. Why should I? What is this problem? You need to explain why should I. Complete search chapter 5 in competitive competitive programmer you mean competitive programmer's handbook. Complete search. I think I reviewed that on one of boring streams. There are 2 streams on this channel, Errichto 2, where I went through parts of that book, Competitive Programmer's Handbook, and I think I went through chapter 5. Can someone directly get a job in Google, Facebook, or something if they perform well on these tough Codeforces problems? You will still have an interview. But if you are good in tough Codeforces problems, you will pass the algorithmic part of the interview. If you also know some technologies, if you have experience with some projects, you know language, then you're likely to get a job. I can't understand the partial something. You should read you should read about prefix sums in a grid. How to compute prefix sums in a grid. Try googling that and reading about it. This problem seems hard. This is the last slide from Dynamic Programming Lecture 2. Random problems. Okay, let's do some drawings. We have a chessboard, and how many pieces we could put there? 1, 2, 3, 4, 5, 6, 7. That's one idea I have. Oh, we cannot have more than that, because the distance between 1 and 8 must be greater or equal the absolute difference I minus j, and that cannot exceed, wait a moment. So for 1 and 8 this is 7, and distance between two cells in this grid cannot be bigger than 7. The maximum distance is between two opposite corners, and that distance is 6. 1, 2, 3, 4, 5, 6. Okay, so this is smaller equals 6. So it shows that it's optimal to just put pieces along the diagonal, like that, like 1, 2, 3, 4, 5, 6, 7. That problem wasn't that hard after all. Let's take a look at the tutorial whether I'm right. First problem. Consider two edge cases, all the Z persons upvote, all the Z persons downvote. Second one. We put if piece on satisfying that. I think this is along the diagonal. Actually, they did not for the diagonal, but first column and then last row or something like that, but the result is the same. And the answer, that minimum size of a grid, is the same. So we're good. We can move to the next problem. Next problem will be C. Is Codeforces platform connected to some companies, or is it completely independent? it's independent, but people know about it. Hello, Mustafa. Your approach is right. I got AC using the same approach. Okay, cool. Problem C. So this is diff 1A. She was playing cards, but found that cards were mixed with some empty ones. There were n cards numbered 1 through n. They were mixed with another n empty cards. 2 n cards in total, n of them are empty. She wants to make the n numbered cards piled up in increasing order. As quickly as possible. Can you tell her the minimum number of operations? If I understand correctly, what is the name of the problem? No, and cards. Remove everything. There are two piles. One is there is she's hand. What cards she has on hand? Like 0 to 0, I think, in example, and then 1 0 3. In one move, we can choose one of our cards, like 0, put it at the bottom of the pile, and instead take the top card from the pile. Or for example, we could take the middle of our cards. This is hand. This is pile. This one goes to the end of pile, and the top card goes to our hand. We want the pile to be sorted 1 2 3. How to do it? Well, if we have some pile like 1 0 3 0 4, then for sure all the prefix that contains some zeros should be taken. Plus, if there is something decreasing after that, it also needs to be taken. Actually, just taking that to hand and then choosing which cards we put to the bottom isn't enough, because after that 2 would be the first card in the pile. So I think from the pile we should leave just a suffix that is of form 1 2 3 and so on up to k. This is the only thing. This is the suffix of a pile that we can leave untouched. What else? In the first move from hand, we should put to a pile number k plus 1. So here the new element will be k plus 1. But if we don't have it on a hand, we're in trouble. Okay, if the suffix is like this, 1 2 3 and so on up to k, then we try putting there k plus 1, k plus 2 and so on up to n. If this succeeds, if this is okay, every next number we can put there because we have it on hand. We're done, and the answer is the number of moves, which is n minus k. Otherwise, if that wasn't successful, then we want to put numbers in order 1 2 up to n in the pile. I think first we do some random moves. I cannot just put a 1 there if I have it on a hand. If I have a situation like, let's say, something, 1, something, something. This is my hand. The pile is something, then 2, then something, something. The first one is hand, then pile. I shouldn't make the first move to put 1 at the end, because then I don't have 2 to put there in the second move. I think I would do binary search over the answer here. Binary search on the number of moves wasted. Then I know some prefix of pile gets to my hand. And I check if then after that I'm able to put here 1, 2, up to n in this order. The alternative way is to see when we will get 2 from the pile, when we will get 3, maybe 3 is here, when we will get 4, and so on up to n, and we take something like a minimum of that. I know if I start at putting the numbers 1, 2, and so on at time t, then at time t plus I need card I at t plus I at this time. From this I can get like minimum over everything and know when I can start, when is that minimum smallest t. Then I don't need binary search. First, try to finish it without playing any empty cards. If that's not possible, the best choice is to play several empty cards in a row, then play from 1 to n. For card I, suppose that it is in that position, you have to play at least that many empty cards. Okay, so they did what I described without binary search. This is, I think, harder than usual. First problem in diff 1, or maybe not. Can I see like standings? Or maybe not. This is not harder than usual. I think this is your average div 1a problem. It took people a lot of time to solve C. Yeah, and stats show that C was much harder than the previous problem. 5,000 submissions, then 1,800. Then a big gap from D to E. Okay, we can continue with the next problem, which is circle. Just requesting you one last time because I have no one else to ask from. I answered you. I already told you that you should, so regarding this formula, I told you that you should Google prefix sums on a grid. Plus, you can ask in Discord on Codeforces. Girl who loves drawing circles. One day she has drawn a circle and wanted to draw a tree on it. A permutation of n elements. After a permutation is chosen, she draws the ith node in the pith point on the circle, then draws the edges connecting the nodes. Okay. 1, 2, 1, 3, 2, 4. So in this problem we are given a tree and we want to count ways to put it in a circle. Every vertex should be on the circle. We need to count the order, the number of ways to rearrange vertices on a circle, plus and edges cannot intersect. In one sample we have something like 1, 2, 3, 4, and the answer was 16. We could possibly do 1, 2, 3, 4. Then the tree looks like that. We also can do 1, 2, 3, 4. A tree looks like that. But there should be some ways that are impossible. I think that would be 1, 2, 3, 4. If this is the order of vertices, then we have intersection, and intersection is not allowed. What are the limits? $200,000. Oh, they have drawings this time, and yep, there is an intersection here. If we have a star where one is connected to every other vertex, all permutations are good. There are no intersections. Let's try to understand when a permutation is good and when it isn't. If there is an edge, ij, let's speak with examples here, between 3 and 7, oh, this isn't not a good idea, between I and j, there is an edge. Then in that tree, I and j are connected, and I is connected to some vertices, j is connected to some vertices. We still can put everything. We can finish the drawing because neighbors of I will be here, neighbors of j will be here, and that's fine. But which situation is impossible? What about that? We can use dp on trees to know the number of ways to arrange, to order those vertices, and number of ways to order those vertices. Then we need to choose which group is on the right or on the left. The group from I, it doesn't have to be in one side. For each of those edges going from I, we need to decide whether it goes to the left or to the right, plus the order between them. If there are three neighbors here, A, B, C, then we can put A and B to the right and C to the left and C to the right, and so on. There are several possibilities. One of those was A, B, then I, then actually let's say J. Okay, that's a different way to think about it. When we have that circle and I, it has several neighbors, A, B, and C. Then we just order them, A, B, and C. Which one is more to the left? then they have independent connected components. So the solution is when we have tree like 1, 2, 3, 4, for every next vertex, you decide the order of its neighbors on a circle. Here I would get 2 factorial, 2 factorial, and that's it. It's 4. But the answer was what, 16? I think it was 16. I think this should be multiplied times n, because we can shift, like rotate the whole permutation by n to like choose where 1 should be. Then for the other tree, that is 1, 2, 3, 4, there are 3 factorial ways to reorder neighbors of 1. This is 6 times n, it's 24. So maybe the answer is the product over degree factorial times n. N times the product of degree factorial. That's a very strange way to implement it. I don't recommend that. Just compute factorials and it will be easier. Compute factorials, then compute degrees and find the product over those factorials. Don't forget about modulo. Then there are 2 versions of problem E. The only difference is constraints, and that those constraints are what? 50-50 versus 200,000, 3,000. And pictures. When she visits, she sees exactly 1 picture. The website does not display each picture with equal probability. Each has some probability, those values are given. When she saw a picture she likes, she would add 1 to its weight, otherwise she would subtract 1 from its weight. She will visit the website m times. She wants to know the expected weight of each picture after all the m visits modulo prime number. Can you help her? We're given weights, initial weights, wi, and whether she likes each picture or not. The name was pictures. By the way, we are 40-something minutes in. I think the stream will last for like 2 more hours, or something like that. I will ping on Discord about the stream, because it's mainly solving problems and people like it compared to more boring streams. Okay, I pinged on Discord. Done. Pictures. Just remove everything. OneNote doesn't have an option. Like, I'm waiting for the update of OneNote. It doesn't have an option to make black background default, and because of that I need to every time just copy the previous page and remove everything. Okay, we have weights, let's say 3, 5, 6, 7, and whether she likes every picture or not. 1, 0, 1, 0. For each picture, let's focus on computing after m steps. M steps, we choose a random picture. If she likes it, the weight increases by 1, otherwise it decreases. We want to find the expected value of the weight of this vertex at the end. What is important, I guess that will be dp. What is important after some number of steps is the number of times we hit this this number. Since we like it, every hit will get +1, +1. dp of hits. After that many hits, the value, the weight will be w of I plus hits. And the other dimension must be other liked, and possible other dimension is disliked or other disliked. After that, if we have that as dimensions, we know what is the total weight of everything, what is the probability that will again hit a 6, and when other liked increases by 1, this increases the total weight by 1. The probability to get a hit again is w of I, or let's finish this formula, w of I plus hits over the initial sum of weights, let's call that uppercase W, plus other liked, plus hits, plus other liked, minus other disliked. Every disliked video hit or picture gave -1. This is P probability that will hit this same value again. This dimension is unnecessary because when we iterate over the ith try, then hits plus other like plus other disliked, the total of that must give us the number of steps. So if we know the number of steps and hits and other liked, we can compute other disliked. This is not a necessary dimension. For now we have a solution that works for the easy version. It is O of, for each of n elements, I have that dp. That is, I think m steps, and dimensions are m squared, m cubic. This is enough to solve easy version, but not the hard one. You might think whether values can get negative because we subtract 1 and subtract 1, but after some value gets 0, it cannot be chosen anymore. The probability of that is 0, so that will not happen. Plus they say it is guaranteed that there is at least one picture which she likes. That means there won't be just zeros. Some number will be liked, and thus it will only increase. And now the question is how to solve this faster. I will get some water because it's hot. I think we could once make dp. So that was one solution. But instead we could once make dp of liked, disliked. That would be, we would just once iterate over all states. That would be m square. And it's just probability int, because we compute values modulo, but this denotes probability of being at some state. And when we know that there is some probability that we liked 5 videos and disliked 2, and we have a new operation, I think we could use that to add something to all the values in the input. If the sum of liked initially, the sum of values of liked videos is 10, sum of disliked is 7, and let's say this value is 3, this value is 1. Then we are right now in state 13.8. No, not 13.8, 13.6, because every dislike decreases this number. And when we get another +1, now we know that this happens with some probability. Then with probability with p equal 10, 13, this affects one of the pictures that were initially given with those weights, while with probability 3/13th, this will stack to that additional weight of something already. I think about it this way. Every picture has some weight. Let's say first picture has weight 5, then second one has weight 3, then third one has weight 4, and so on. after I get new something, every new like is kind of connected to one of previous weights or points. We can say that we have a forest and we attach a new leaf to a random vertex. This way the ith picture will get something with probability weight of I. What about this? It looks easier for just those pictures that are liked. Then I would say if one weight is initially twice greater than the other, on average it will stay twice greater, because the probability of adding something there is twice greater. Or is it not true? Yeah, I think it's true. But looks worse for those disliked pictures. So I will say the following. At the end, if I have some probability of getting from initial state 10 and 7 to the final state 13, 6, I will say that each of those 3 extra liked videos, this is equally distributed among all the pictures. I mean, with those weights that are given. For example, if the weights given of liked pictures are 8, 4 and 2, and I want to distribute plus 5, then I will distribute that with those weights. If this one should get plus x, then this one gets plus 2x, this one gets plus 4x. I divide 5 by 7 and distribute those accordingly. Disliked is also chosen at random from those disliked pictures. Here if we have 3 here and then 1 here, and those are disliked, 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 then removing 2, let's say the total weight of 2 from those, means removing 2 random out of those right now 8 points. And I think this solves the problem. We apply DP, the two-dimensional DP. This way we compute the expected value of the number of added points liked this thing, and the expected value of the number of disliked things, the lost total weight, and then using the sum of disliked weights and the sum of liked weights, we distribute that evenly. The complexity will be m squared plus O of n times maybe inversion from modulo. I would like to see your solution on this problem. Is there something interesting about this problem? Does it have a tutorial? Easy version. Let's focus on a single picture with weight W that she likes. And we have dp sum of positive is j, sum of negative is k. So it's, I think, the same dp as I did. I didn't write. Oh, I had that. I thought in terms of probabilities, I guess, and this is the expected weight. Then hard. Oh, this was harder part already. Yes, it was. Where does the hard part start? To solve the hard version, let's introduce the lemma. What is upper index? What is lower index? I think it's the initial weight. So they prove that indeed those points are distributed evenly. And I don't like the fact that this is all with algebra. I think I have a better proof. Let the sum of initial weights be that. What happens is equal to the sum of expected weights, basic probability, therefore this is equal to the sum of expected weights. I will just quickly write my own proof. In here, can you again prove that lemma? Yes, I'm just writing down this comment. The alternative proof for the main lemma in that. There are n trees. The ith of them has wi vertices. Sometimes you add a new leaf and attach it to a random vertex. Let's focus on adding. Let's assume that she likes all the let's focus on a case where she likes all the pictures. if there are W vertices initially and I don't know, X new vertices, the added vertices, there is a new vertex is either attached to one of initial vertices, starting vertices, existing vertices, then the probability is WA over the sum, or their entries, the ith of them has WI vertices. M times you add a new leaf and attach it to a random vertex. A new vertex is either attached to one of the initially existing vertices, then the probability is that, or I can write sum of WI or the other case is or it is attached to one of already added vertices. This gives us a trivial proof by induction. If probability of a new vertex, if probability of adding previous vertices in previous steps of adding a vertex to the ith tree in previous steps is WI over that, then it's the same here in this step when we attach the new vertex to a random to one of vertices added in previous steps. That's the proof. Their entries, the ith of them has WI vertices. M times you add a new leaf and attach it to a random vertex. New vertex is either attached to one of the initially existing vertices, or it is attached to one of already added vertices. This gives us a trivial proof by induction. If probability of adding a vertex to the ith tree in previous steps is that, then it's the same in this step when we attach the new vertex to one of vertices added in previous steps. So probability is that in every step. Hello, Suraf. So we solved, I got a solution for E with a proof, and we can move to the next problem, which is F, portals. n times n grid, rows and columns are numbered. Portal is a pair of doors. Let's copy this thing, paste it, and analyze just on this example what happens in the problem. The problem is called portals. Copy, paste. Can I increase the size? I can. When we enter if I understand correctly, we enter grid. This is not the best color. I think the best one might be black. Maybe just thicker blue. When we enter a grid and we meet a portal, we go to another portal of the same type. Then here we would get to A, and from A here, and so on. From this starting cell we would finish here. Then another example will be to get from this C, again thicker color please, then we would get here. B, C, C. Okay, and we are given a permutation for every starting cell on the left where we should finish on the right, I think, and the same for everything on the top where we should finish on the bottom. Is that correct? If you walk into that facing right, in the first column, if you start from the left side, you will eventually exit the grid here, and everything are permutations. Find some grid that will give you that permutation. You need to create that grid with portals. Let's say from this one you need to get here, from 2 you need to get there, from 3 to 3, from 4 to 4. Let's focus on this part, then we'll adding from top to bottom. From 1, let's put portal here. Then from 2 we need to get the other 2, from 4 to 4. Okay, This way we are done with rows, but what happens then with columns? If we enter here, we would get there, 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 there. I messed something up. From this A to that B, that C, that A, B. Okay. Doesn't look trivial. One moment, I need to answer my phone. I mean, text message. The samples didn't, the statement says that you should print -1 if it's impossible, but the samples don't have a case with -1, and then my guess is that it's always possible. We can start with n equal to 2. If we need to go from here there, but swap columns, is there a way to achieve that? I don't think so. No matter what I do, the drawing will be symmetrical, or won't it be? I can, okay, I can do that. AA, and we're good. A pair of adjacent portals, not necessarily adjacent, but in the same row, it swaps the two columns. And it doesn't affect rows. Maybe that's useful in a big grid. If those two, I and J, should be swapped, then it's just about putting a pair of portals here. It doesn't change any row. If I have more complicated situation, like a cycle, the permutation gives me a cycle I, J, K, and here it's J, K, I, then it will be, I guess, A here and then B there. Right, from I would get there, for J I would get here. Yeah, it works. I swapped columns IJ and then columns JK. Recent contest hosted by MCDIC was also nice. It will good to you provide your insight on some hard problems. What is MCDIC? Can you give me a link? We are given a bunch of columns that we want to swap. There could be linear number of them. And can they be in the same row? If I swap I and J and K and L independently, I think I can do that in the same row. I have those pairs that I need to swap. I can decrease the font now. I and J, J and K, and so on. Maybe some other pair. And I need to put those pairs in the grid. The same for pairs of rows. And then something like CC, DD. And then I need to squeeze somewhere EE. They shouldn't coincide. They shouldn't, no two portals should be in the same place. And it looks a little bit like matching. Or maybe not. If every cell is an edge, I don't think that's a good approach. Grid might represent a matching. It can be a matrix of adjacency. MCDIC is user in Codeforces. He made Codeforces around 566. Okay. I might take a look if I have enough time. Not him alone, of course. Well, it's not that obvious that not him alone, so I wouldn't say of course. Some people make their own rounds. I made, I think, several rounds. How to put those pairs in a grid so that there would be no collisions. One idea I have is to just do everything randomly and repeat that till it works. Every pair, like pair IJ here, just put in random row. For example, maybe it will be here, AA. And my guess that is that there will be collision with some constant probability. If I repeat that a few times, I'm good. There are still testers and other people involved, right? Yes, there are. I mean, usually what you say is who is a problem setter. This is how I understood it. I will take a look at the link later for that contest. First, this one for sure. What were the constraints, by the way? How you create problems? What is the process? You invent problems, then you propose them. You can Google like Codeforces proposing a problem, and there is description of that. It's a long description. Then for preparation of problems you use Polygon, which is system where you create tests, solution statements, and so on. Where are you going for the 2-3 weeks you mentioned in the last video? Saudi Arabia. I will be in a programming camp teaching them to IOA. I would here during a contest already implement the randomized solution, and I wonder if there is some other possibility. I'm not sure. Let's read the editorial. The person in that facing right is numbered that. The person there facing bottom is numbered bi. We have a recursive solution. We satisfy the problem for the first row and column and then run recursively. The person in ij facing right is numbered ai. The person in 1i is facing bottom is numbered bi. The person numbered pi has to exit the grid from that. This is exactly the problem, right? The original problem can be easily transferred. I don't get this part. This is just the problem that was given. Or maybe the inverse permutation. So we want to do something with the first row and the first column. Let's say that A needs to get there, B needs to get there. Then I don't know, C needs to get here, D needs to get here. And what do we do? From A to B. If I put a pair of portals there, then B gets to its position, D gets to its position, C will be now here, and A will be here. Okay, that was easy. Okay, and what if the first row is done, AA, but then we have DD. I need this pair of portals. D will get here, and I will just walk there. Cool. Okay, done. I'm not sure if the randomized solution would work. It doesn't change much. The solution is fine. That's all of div 2 problems. The last one wasn't that trivial. And then there is div 1, and I think that div 1 was very hard. Portals was solved by more than 100, but then 30 and 17, and yeah, nobody solved it during a contest. Just in app solving. I can read them, but if nobody solved them, it means they are just crazy hard. E. Hello, Aman. There is a tree, each node has a color. She wants to calculate the sum of the number of different colors on all different paths. Can you help her? There will be m modifications. Each modification will change a single node's color. Okay. If there were no modifications, you would need to compress the tree for every color and then focus on one color. For that color, count like number of paths that don't contain this color at all. Here, if there are queries, then I would do divide and conquer over queries. I saw a similar trick recently. You have all the queries, but then when you go to the first half of queries, compress everything other than those vertices that will be affected by queries. And when you go to smaller segment of queries, you have a compressed tree. But it's just very unpleasant. Let's see if that's the intended solution. I like the drawings. For each color, we delete all the nodes that belong to such color, thus splitting the tree into some clusters. We maintain cluster size square. We should use link cut. Let's focus on two colors, or well, one special color, and then something becomes this color or stops being this color, and what happens? Reverse the color of node 1. Clusters change. They are connected to each other. I'm not good in structures like link cut. My solution, my path to a solution would be completely different. Okay, and I will then just read the next problem. Hello, Jason. What's the topic? Solving Codeforces problems. The last one in that round 564 is bug. One day she was solving a problem which requires to calculate a sum of some numbers modulo p. She wrote the following code and got the verdict wrong answer. She soon discovered the bug. The mod add function only works for numbers in range 0 to p-1, but the numbers in the problem may be out of range. We can add two numbers modulo p if they are up to p-1. If they are huge, we need to apply modulo operator. You're given an array and number p. M queries. In each query you are given L and R, and you have to calculate the results of that. You can see the definition of the sum function in the pseudocode above. Oh, the numbers could be negative. I guess that might make the problem harder. During the contest I would try this problem. It looks cooler than the previous one. We are given a sequence of length 1 million and there are queries about intervals. Then if you just consider interval, to every number apply this function and say what is the result. I would try drawing this. You can build a segment tree. Square root won't be useful because n is too big. It's 1 million, so likely it's a segment tree. Then when we have some new numbers, I want to know when that exceeds p, then it will start decreasing. Looks like a cool problem to think about, but I know from standings nobody solved it. So I don't think I will spend much time on this problem. Okay, I need to stop for like 2 minutes to do something else. I will be back in 2 minutes. Okay, I'm back. So do I want to try solving this problem? I can at least start. I can do something, but I guess I will quickly give up. Remember, if you want to really practice to get better and better, you shouldn't do what I'm doing now, where I quickly went to the editorial. It's just that I don't care that much now about practicing. I just want to see solutions, maybe find some cool problems, that's it. Let's focus on a case with p equal to 100. That will be easy to think about. Then when we have some sequence, the numbers like 240, then 5, 5, 5. Starting from this 240, we'll get minus 100, minus 100, and so on, every step. Basically, the code is for every I, do s plus equal t of I, a of I. Then if s greater equal p, s minus equal p. We can say this is repeated for I in from L to R. We should simulate that quickly. There could be negative numbers, but for now I will not think about them at all. If all numbers are between 0 and p minus 1, we will simply compute the value of that interval modulo p. What I need to know is how many times I will go down, or what is the Fahrenheit value. By going down, I mean how many times this will be executed, because it's easy to compute just the sum of elements. The question is how many times I will decrease p by p. I can think about prefix sums. Then if I write prefix sums in this interval, what I'm getting is at every position, let's say here, I see here 2 full 100s. This means if the previous number of decreases was smaller than 2, then decrease. If x, the number of decreases, is smaller than 2, then x plus plus. And then x will compute the number of decreases. I would say that for every position, if we are already above 100, I'm looking for the next place where I will go below 100. We can also treat those numbers as real values. This is 2.4, 2.45, 2.5, but I don't think this will help us in any way. We can think about it as we were walking through a circle. When we exceeded 100 in some position and we have value like, let's say, 170, we're looking for the next position. Maybe that will be binary search, that 170 plus this sum in the interval. This doesn't exceed, let's say this is sum s, 170 plus s is smaller than minus 4 times 100, where 4 is the length of that interval. This should be smaller than 100, which means this can be represented as the sum over number ti minus ai minus 100. If I change every number to ai minus 100, then I know as long as I'm above 100, I'm adding those numbers instead of initial ones, because I'm decreasing by 100. And I want to know how many numbers to the right I need to add to get below 100. Then I switch back to adding normal numbers instead of that. Well, for this position, we could binary search in a tree, something like that. We could find that first interval that has prefix sum of those values, ai minus 100, prefix sum must be smaller than something. It would be nice to remember that from this position, if we get here, then from this position here, those will be in every such interval, this one, then this one, and so on. Every interval will mean alternatively taking numbers ai in one and the other taking numbers ai minus 100, because we exceeded the value of 100 and we are decreasing every step. It would be nice to remember that, but the bad thing is this last part of the number we are currently having, 170, matters. If it was 180, for example, then we would have to go even longer with that first interval to get below 100, because we would be further away from that. This means it isn't enough to just remember those things or make dp once from right to left. So I'm not sure what to do. Okay, I think I will read the tutorial. If you want to try this problem yourself later, then you should stop watching now for this next several minutes. This is tutorial for the last problem from recent Codeforces Division 1 round. Okay, I thought first about square root, but I quickly got rid of that idea simply because n is too big. Apparently from that solution they get to better one. So let's split our array into blocks by b integers. And for every block of size square root of n, precompute something. To answer the query, you can keep the current value of x and then find with binary search by that piecewise linear function for the current block. How to solve it? That each segment of this piecewise linear function has length at least p. there is some piecewise linear function that says for given x, after we go through some block, what will be the final value. Then there is lemma, each segment of this linear function has length at least p. I don't know why. I guess starting with value bigger by p, you can end up with the same value of or with value bigger by p. So that function with just, or the number of x's, the number of times will decrease depending on the starting x. Let's call that s0, and here decreases. It will be something like 0 decreases for some initial sum 0 smaller than something, then 1 decrease, then 2 decreases, 3 decreases, and so on. And if this is, let's say, x, then the value at x plus p must be same or bigger by 1. Then this value must be same or bigger by by 1, and so on. This means the number of those intervals cannot be big. But is that enough? What does query do? We built a segment tree. I guess this is a segment tree. Okay, and vertex responsible by I don't know, a consecutive points, it will have a function that has size a. Okay, I got the idea. Let's see if people talk about it. Let's refresh the tutorial. Okay. So this division 1 contest is done. I got the idea of a solution, it's cool. Fortunately, I'm quite good with those piecewise linear functions. I usually solved such problems in my ICPC team. Here I didn't see a solution, but because it was hard, I would be able to implement the contest. Here I wanted to check the discussion tab. Somebody asked me about some contest, saying this is nice. 566. Okay, I don't know, maybe I will check it. First I want to read this block. And then we'll see. Division-free problems should be easier. Blah blah blah. Information in the right says that in average, in a division-free round, only 3.7 problems from about 7 in total have difficulty 1600 or less, which is only 56% of all problems of the round. We'd compare that with statistics on educational round that are pretty much prepared by the same people. Round number in the first row, amount of problems with difficulty 1600 or less in second row, total amount of problems in the third row, amount of problems with difficulty that or less. So here we have like 3 out of 7 problems on average. Here we have 4 out of 7 problems on average. The statistics says that in average educational rounds have only one easy problem more than division-free rounds. And educational rounds have the same problem when only 4 out of 7 problems have the difficulty 2100 or less, which is the target audience. Last 3 problems of those rounds are only solved by a few people, mostly from out of competition. How could we fix that? I like the analysis, and I agree that division-free and educational rounds should be easier. Don't trust the high-level problem ratings in Div 2 free rounds. It is illusionary because the problem is considered to have beaten a lot of weak rank players. It is sort of like how some chess players beat up a bunch of low ranks to artificially inflate their ratings. I don't know how exactly problem difficulty is calculated. It's a recent thing. A few years ago there was no such thing, and you could just see the number of accepted submissions. It's 2 p.m. I can see some problems from that round 566. This is Division 2 contest this time. You're given n, find the number of ways to fill 3 times n tiles with the shape described in the picture below. This picture describes when n is equal to 4. That's some strange English. You need to take those shapes and fill 3 times n grid with them. Print the number of ways to fill. The statement is quite bad. I guess we could put a tile here, the other one there. Can we rotate? I guess we have to, because otherwise we couldn't fill this place. The statement is very, very bad. You need to say whether something needs to be rotated. English is kind of broken. There is no example how to fill. I don't like the problem. I guess that we need to put one shape here, the other here, or the other way around. One there, one there. The answer will be 2 to the n over 2. Unless n is odd, then there is no solution. Yeah. check if there is plus shape. The constraints allow n-cubic solution, so we should iterate over cells. For each cell, try going to each of 4 sides, up, down, left and right as much as possible. Count the stars as you go and check if it's equal to the total number of stars in the grid. That's one of the solutions. It's for sure also solvable in n squared, but whatever. I would find the longest row with stars, the longest column with stars, and that would be my only case. Or like find the only row and column that have more than 1 star in them, and those are candidates. If there are none, then something with 1 star. Tutorial. Oh, this is tutorial. I think he's Korean, so English is not good. Yes, but there are people working in Codeforces who are like responsible for polishment of statements. But he made a really interesting editorial. At least I found it nice with all the backstories. Then that's cool. First, trying to find if there is any non-empty space. I'm just saying that the statement of problem A was bad. Plus, there were no examples how to fill it. I didn't like the drawing, where you say the description shows something, but it showed actually 2 shapes, the rectangle and the shape you need to use. It didn't say that you need to rotate them. Coordinators should check that, should like watch for those things in the statements. Or well, setters should, but not everybody is experienced. First, try to find if there is any non-empty space which has 4 neighbors. Oh, because the statement said you need those 4 neighbors. Then indeed you can. And quadratic complexity behind story. Oh, so original B was harder. None of those testers solved it, so it was downgraded. And then story for C. I can read it after maybe solving C. Yes, I made the program that uses both of the shapes from the picture at first, so that took some time away. Yeah, because they showed 2 shapes. First saying this is the shape you can use. I wonder what's the story behind username MC Dick or Mac. You're given n words, each of which consists of lowercase. Maybe it's short for his name? I don't think so. Each word contains at least 1 vowel. You're going to choose some of the given words and make as many beautiful lyrics as possible. Each lyric consists of 2 lines. Each line consists of 2 words separated by white space. The number of vowels in the first word of the first line is the same as the number of vowels in the first word of the second line. Same for second. The last vowel of the first line is the same as the last vowel of the second line. Those are vowels, Y is not. How many beautiful lyrics can you write from given words? Note that you cannot use a word more times than it is given to you. For example, if a word is given 3 times, you can use it at most 3 times. That's a very unpleasant problem. The statement is long, there are multiple conditions. It's not that bad, but I saw better problems. For each problem, each word should be described by the number of vowels and the last vowel. Then we need, the first word needs to have the same number, the second word the same number plus the same last vowel. So we can gather, it will be easy to double count something. We need to gather all the words with the same count, all the words with the same count and the last vowel. Kind of, I would say, iterate over what pair the number of vowels and the last vowel will be the second word. You have some number of ways to choose that. And the problem would be much easier if it was guaranteed that every word exists just once in the input. C is created before few days before the contest. If there was no current C, the contest would have hell balances. Let's make some definitions. What? Oh, I misunderstood the problem. We need to pair them. I thought we need to count everything. Count the number of ways to choose for words. Then, if possible, we use a pair of words as the second word. Otherwise, first, and that's it. I thought we were counting. Then the solution is fine. Just maybe a bit lengthy. Hello, Brian. You're given. You have given 3 consists of. Did anybody check the statement? You have given 3 consist of n vertices. Select a vertex as root vertex that satisfies the condition below. It satisfies the condition below. If distance from the root to 2 vertices is equal, then degree is equal as well. This means if you have the root, then children, grandchildren, and so on, in every layer, all the vertices have the same degree. Determine and find if there is such root vertex in the tree. If there are multiple answers, find any of them. Well, this suggests we should check yes or no. Determine and find if there is such root vertex in the tree. I would say this means yes or no, but then if there are multiple answers, find any of them. Still, I would treat that as yes or no. I get that they meant find at least one such vertex. Okay, what do we do here? We compute degree for every vertex. Maybe root somewhere. If 2 subtrees, if 2 children are the same, you can merge them into one to decrease the number of vertices. For subtree, I can store for every depth in that subtree what is the degree of vertices there. Let's consider that as an example. The problem is complete mirror. One, two, three, 4, 5, 6, 7. Let's also use extra here. Instead of numbers, I will just write down degrees. There's one vertex, the other here. One, three, one, three, 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 one. If for a subtree I store a list or vector, something like that, for every level what is the degree, I can merge that, smaller to greater. Then for that subtree I would have 3, 3, 1, and then I couldn't merge that with 1. And maybe when I cannot merge, I just stop and say this must be the answer if there is any. After first rooting the vertex at, let's say, vertex 1. So vertex 1 is the initial root. I do bottom up DP. If I cannot merge two children, I say I need to stop, and this is the candidate for the answer. I root again and I repeat DP. I don't really need to do that bottom up DP. I could write for every layer, I could gather the values. Here for 3 and 3 everything is equal, and I would find pairs of consecutive things in the layer, in the same layer, that are not equal, and I then find their LCA and say the root must be here or earlier. No, here or more down, because if the root is more to the up, then degrees down do not agree. Something like that. I don't know, it's some idea. Let's see what does editorial do. Behind story of D. Honestly, I predicted D as hell hard problem, but other high rated people said it's not that hard. The value tree should form like the picture below, unless the whole tree is completely linear. This node is the top of the tree. This node has always degree 1. This node is always one of the possible answers of valid tree. There might be no top node in the tree. What? Sum it up. This node is the closest children from the top node that satisfies degree greater equal 3. In other words, this node is the end of the leaf branch, which includes top node as leaf. I don't understand this. This node can be one of the possible answers of valid tree. We do something special for degrees greater equal 3. Do I understand the problem correctly for sure? Every layer should have the same degrees. And find the root. Okay. Let's see what are the solutions. There are two. One, find the diameter path and validate for two leaves of the diameter path. If no valid vertex found... Oh, that's smart. Leaves must be in the same layer. Other than the top leaf, possibly. Cool, that's a cool insight. Then the semitop should be the middle of the diameter path. Now validate for the semitop and the closest directly reachable leaf from semitop. Then clone the whole tree and cut the leaf branches. Include top from the clone tree. This is inner tree. And then something with cutting leaves. Oh, okay. I didn't understand the editorial either during the competition. I did I don't know this word. Rerouting DP with hashing to check if two subtrees are the same. Yep, I think we can avoid hashes if we are very smart about going first up and storing that degree for every depth on some vector where you merge smaller to larger. Then you need to do the same. So first you did bottom up, then you need to do the same top down. Okay, problems. There are two to go. F is something. Find Fn modulo billion. Fx is some crazy function. I'm almost sure that this can be solved with Massey, Barley-Massey algorithm, because here you have recursive function with a product, but if you think how many times c will be in the answer, that exponent of c is added every time. So that should be polynomial. Not polynomial, but this will be plus that and exponents here. The function of how many times c will be in the answer will be, I will just write it here, like f of x is that 2x minus 6 plus f of x minus 1 plus f of x minus 2 plus f of x minus 3. This is very similar to Fibonacci, and you can do that with matrix exponentation or with Massey. I guess it's similar with just f1, f2 and m3. So there are four constants. For each of them, compute the exponent in the final thing. This one looks very easy. Yep, and F. Oh, I closed F by mistake. You are given integers a, b, p, and q. Let fx be that. I don't want to solve this problem. It doesn't look pleasant. absolute value of sinus of p over q times pi times x. Find minimum possible integer x that maximizes fx where x is between a and b. Looks like number theory problem. Again, I will just write here quickly. I understand that we are on a circle of angles, and if we have that first angle p over q times pi, then we're kind of making jumps with every next x. We're making jumps like that and so on, and we want to be as close to 90 degrees as possible, or 270 degrees. And looks like extended Euclidean algorithm. Yeah, we want to be as close to possible to some value. Find minimum possible x that 2px mod 2q is the closest to q. Exactly. Looks like baby step, giant step, which is similar to a lot of number theory algorithms. Yeah. So, rating problems. E was trivial, D wasn't, C was. Oh, and the number of solutions shows that. For E, I knew solution after seconds. I would solve D with some troubles, and F, I think it would take me some time, but I would also solve it. I see that Marek Sokolowski won even without solving B. Is that possible? Does he have that big advantage? He finished in... Okay, he finished in 1 hour when others finished in 2 hours. Then that makes sense. It took a lot of time for people to solve D, I guess. What makes sense? Okay, is there anything new written on Codeforces? If not, then we're finishing the stream for today. The next one will be on Monday. Nothing new. Okay. I think I will suggest the full round, the full topcoder round soon. Maybe my round will be scheduled in the near future. I will work more on my dynamic programming lectures. Subscribe to youtube.com/Errichto for that, the main channel. Also links are in the description. I don't know what else. Like the video, subscribe to the channel if you haven't, and see you in the next stream or on Monday. There is schedule I think under the Twitch video. There is countdown to the next stream. Hello Harsh, and see you. Bye bye.